10, section 7.6, angles and polygons. Let's begin with a check of the skills you'll need. Number 1, vocabulary review. What is the sum of the measures of a pair of supplementary angles? And find the measure of the supplement of each angle. All right, moving on to what you'll learn. To find the angle measures of a polygon. And there's some new vocabulary. Interior angle and exterior angle. Why learn this? Well, polygons often appear in art and architecture and all over in nature and in real life. In designing tile patterns, in this example, it helps to know about the angles of the polygons. Here's a list of common polygons. We're very familiar with a triangle, that's a three-sided polygon, quadrilateral being a four-sided polygon, pentagon, a hexagon, heptagon, nonagon, oh, I missed octagon, then nonagon, decagon, and dodecagon. Two consecutive sides of a polygon form one interior angle. Remember, interior meaning inside. The sum of the measures of the interior angles depends on the number of sides. We'll look into that a lot more very soon. The key concept, polygon angle sum. For a polygon with n sides, the number of the measures of the interior angles is n minus 2 times 180 degrees. So we're given this new formula. For a polygon with n sides, the sum of the measures of the interior angles is n minus 2 times 180 degrees. And that's probably true. It was told to us in a digital textbook. It makes some sense. But let's check it against two different polygons that we're pretty familiar with. So starting with a triangle here, we have a triangle which we know has 3 sides, so n equals 3. And we know the interior angle sum of all triangles is 180 degrees. And then on the right I have another example. When n equals 4, we have a quadrilateral. This particular quadrilateral is a rectangle, and it makes good sense that since rectangles have 4 90-degree angles, that adding up those angles would give us 360 degrees. So let's check this information, or check this formula, using information that we know about these types of polygons. So if n equals 3, well, our formula would give us then 3 minus 2 times 180 degrees. 3 minus 2 we know is 1, so 1 times 180 degrees does equal 180 degrees. So formula works for triangles. That's good. How about quadrilaterals? N would equal 4. So 4 minus 2 times 180 degrees. 4 minus 2 is 2. 2 times 180 degrees. And 2 times 180 degrees is 360 degrees. And sure enough, that's what we know to be the interior angle sum of at least rectangular quadrilaterals. All right, so let's move on to example 1, sum of the interior angle measures. What is the sum of the measures of the interior angles of a nonagon? So we could refer back to the table given to us at the start of the section. That could be a really useful table until you get some of these more fresh in your memory, possibly memorized. Interior angles of a nonagon. So nonagons have 9 sides, therefore we're going to substitute 9 for n. 9 minus 2 is 7, and 7 times 180 degrees, 1,260 degrees. The sum of the interior angle measures of a nonagon, 1,260 degrees, written out in a nice sentence for full credit. Time for your quick check problem. What is the sum of the measures of the interior angles of a heptagon? You can use the same formula to find angle measures in a polygon. Example number 2, angle measures of a polygon. So in this case, we're given a polygon and we know all of the angle measures except for one. Since we can determine the interior angle sum of this polygon, we know that all of those angles added together must equal a certain amount. Therefore, we can solve for the one unknown value by using a variable and some basic algebra. So let's see how the book does this. Step 1, find the sum of the angle measures. Well, n minus 2, so we need to count the number of sides of this polygon. 5, it's a 5-sided polygon, making it a pentagon. And notice this is not a regular pentagon. We have varying angles, we have varying side lengths, and it doesn't look like the building, the pentagon, or what most people think of when they think of a pentagon. But this is a pentagon nonetheless, just not a regular pentagon. 5 minus 2 would be 3. 3 times 180 degrees equals 540 degrees. Therefore, we're able to set up the equation. 540 degrees equals 90 degrees plus 75 degrees plus 130 degrees plus 135 degrees plus x degrees, our unknown angle measurement. Simplify by combining like terms, subtract 430 degrees from both sides to find that 110 degrees equals x degrees, meaning x equals 110. And a quick double check, we could add all those values back together and ensure that we get a sum of 540 degrees. And your quick check problem. Number 2, a hexagon has 5 angles with measures of 142 degrees, 84 degrees, 123 degrees, 130 degrees, and 90 degrees. What is the measure of the 6th angle? And a new definition. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. The measure of an exterior angle of a triangle is equal to the sum of the measures of the interior angles at the other 2 vertices. So that means that the measure of angle 4, that's our exterior angle in the figure, is equal to the measures of angles 1 and 2 added together. Those are sometimes called the remote interior angles. So in this case, angle 1 plus angle 2, their measures will equal the measure of angle 4. And example problem number 3, finding the measure of an exterior angle. The diagram shows a portion of the design of a mosaic. Angle 2 is an exterior angle of triangle ABC. What is the measure of angle 2? Well, we know that the measure of angle 2 will equal the sum of the measures of angles A and B, which are 45 degrees and 90 degrees, respectively. 45 degrees plus 90 degrees is 135 degrees. Therefore, angle 2 measures 135 degrees. And we can check this by the angle sum of a triangle. Measure of angle 1 must equal 180 degrees, right? The interior angle sum of all triangles, 180 degrees, minus 45 degrees, minus 90 degrees, and that's 45 degrees. Angles 1 and 2 are supplementary, right? That means they add up to 180 degrees. So the measure of angle 2 equals 180 degrees minus 45 degrees, and that's 135 degrees. Time for your quick check problem to ensure that you understand these concepts. In triangle RST, measure of angle R is 63 degrees, and the measure of angle S is 84 degrees. What is the measure of the exterior angle at vertex T? So feel free to grab a piece of scratch paper if necessary to sketch or draw this figure. Label the appropriate components and see if you can determine the measure of the exterior angle at vertex T. And here are your check your understanding problems. Again, these are here for your information. You can pause the video and just complete your work from this page. You may screenshot from the video and print. But here you go, check your understanding problems as assigned.